This conference will now
a
be
couple
recorded.
minutes just in case if anyone is coming in, but we'll slowly transition into the lesson. My apologies if there's any technical difficulties. I hope you can hear me. If not, please let me know. But this is EOM 436.01, which is explain winds. All right, so the objectives by the end of this lesson, you should be able to explain different types of winds. The importance of this, it's important for jets to explain winds as this information is used by pilots to be aware of direction and speed of wind during parts of flight. So being able to explain winds provides knowledge for potential instructional duties and is part of fundamentals that cadets pursuing future aviation training will require. So teaching point 1, we're going to explain the surface of wings. So wind is a major factor in flight planning and flight characteristics. So specifically, pilots must constantly be aware of the direction and speed of the wind during flight, and especially when they're close to ground during takeoff and landing. Surface friction plays an important role in the speed and direction of the surface winds. And the friction between the air and the ground slows the air down, causing a lower wind speed than would be expected from the pressure gradient. The friction also changes the direction, causing the wind to blow across the isobars towards the center of the low pressure area and away from the center of the high pressure area. So some basic information is the effect of surface friction usually does not extend more than a couple thousand feet into the air. So at 3,000 feet above ground, the wind blows parallel to the isobars with a speed proportional to the pressure gradient. So hills and valleys substantially distort the airflow associated with the prevailing pressure system and the pressure gradient. Katabatic and anabatic winds and mountain waves are examples of wind phenomena in mountainous areas. So katabatic and anabatic winds, I hope I'm pronouncing that right. So at night, these sides of hills cool by radiation, and the air in contact with them becomes cooler and denser and blows down this slope into the valley. So a katabatic wind is the term for downslope winds flowing from high elevations down to valley slopes, down the slopes to valleys below. So if the slopes are covered with ice and snow, the katabatic wind can also carry the cold, dense air into the warmer valleys during the day. So anabatic wind occurs during the day when the slopes of hills not covered by snow are warmed. So the air in contact with them becomes warmer and then less dense, therefore flowing up the slope. So to the diagram on the right, I'm just going to let you look at that and connect the information to what is on the slide to the photos. So mountain waves. So air flowing across a mountain range usually rises smoothly up the slope of the range. So once over the top, it pours down the other side with considerable force, bouncing up and down, creating eddies and turbulence. It also creates powerful vertical waves that may extend for great distances downwind of a mountain range. This phenomenon is known as the mountain wave. The most severe mountain wave conditions are created in strong airflows that are blowing at right angles to the mountain range in very unstable air. So if the air mass has high moisture content, clouds of a very distinctive appearance will develop, so thereby serving as a warning to pilots. So orographic lift causes a cap cloud to form along the top of the ridge. Lenticular, which is lens-shaped, clouds form in the wave crescents aloft and lie in bands that may extend well over 40,000 feet. So the rotor clouds reassemble a long line of stratocumulus clouds and form in the rolling eddies downstream. So to elaborate on mountain waves may cause many dangers to aircraft. So the following is common downdrafts of 2,000 feet per minute along the downward slope, extremely severe turbulence in the air layer between the ground and the tops of the rotor clouds, severe wind shear due to wind speed variation between the crest and troughs of the waves, severe icing due to large supercooler droplets sustained in the strong vertical currents, and an altimeter error of more than 3,000 feet on the high side due to the increase in wind speed and accompanying decrease in pressure. So gusts. A gust is a rapid and irregular change of wind speed and may be associated with the rapid change in wind direction. So gusts are caused by mechanical turbulence that results from friction between air and the ground and by the unequal heating of the Earth's surface. So particularly during hot summer afternoons. Wind gusts are hazard to gliders due to the light weight and relatively slow stalling speed. Therefore, the Air Cadet gliding program has a maximal permissible gust differential of 10 knots, which is 12 miles per hour. Any gust differential beyond this will require an immediate shutdown of gliding operations. So squalls. A squall is a sudden increase in the strength of the wind of longer duration than a gust, and like a gust, may be accompanied by a rapid change of wind direction. So squalls may be caused by the passage of a fast-moving cold front or even a thunderstorm. So confirmation teaching point one, in the comments, or you can turn on your mics. Can you guys explain anabatic wind? Radiated wind, yep. So just to elaborate, the anabatic wind occurs during the day when the slopes of hills are not covered by snow and are warmed. The air in contact with them becomes warmer and less dense, therefore flowing up the slopes. Yes, exactly. Correct, guys. All right, so question number two. What types of clouds are caused by mountain waves? Yes, exactly, Sergeant Picotto. So rotor clouds, cap clouds and lenticular, and yes, also Corporal Hersey as well. And yes, so last question, what causes gusts? Wow, awesome, Flight Sergeant Mohammed. Gusts are caused by mechanical turbulence that result from friction between air and the ground and the unequal heating of the Earth's surface. Yes, as well, Sergeant Lee. Awesome job, guys. All right, so we're going to move on to teaching point 2, which is describe jet streams. So jet streams are narrow bands of exceedingly high-speed winds that exist in the higher levels of the atmosphere at altitudes ranging from 20,000 to 40,000 feet or more. They flow from west to east and are usually 300 nautical miles wide and 3,000 to 7,000 feet thick. So winds in the central core of the jet stream are generally between 100 and 150 knots, although they may reach speeds as great as 250 knots. So on the right here, the diagram demonstrates the northern hemisphere, which has two streams. So the mid-latitude polar jet, which is one usually affecting weather in the North America, and the Europe and Asia, the subtropical jet. So when the mid-latitude jet is farther north in Canada, the weather to its south tends to be mild or at least less cold. When the stream swings south well within the United States, especially in winter, very cold, often harsh weather prevails at the surface of the northern side. So, knowing the location of a jet stream is important when planning long-range flights at high altitudes. So, for example, on the eastbound flight, a pilot would want to take advantage of the excellent tailwinds a jet stream would provide. So on a westbound flight, they would want to avoid the wind. So clear air turbulence. So clear air turbulence is a bumpy, turbulent condition that occurs in the cloudless sky. It occurs at high altitudes, usually above 15,000 feet, and is more severe near 30,000 feet. The most probable place to expect the clear air turbulence is just above the central core of a jet stream. So CAT is almost impossible to forecast and can be severely enough to be a hazard to modern high-performance airplanes. So therefore, knowledge of areas in the CAT is most likely to occur and is important for pilots to help minimize encounters with it. So now we're going into the confirmation of teaching point 2. So question 1, can someone describe or explain what are jet streams? Yep, for sure, Flight Sergeant Mohammed. Awesome. Do you know? Yes, there you go. Awesome. Yeah, you got it exactly. So jet streams are narrow bands of exceedingly high speed winds that exist in the higher levels of the atmosphere at altitudes which Flight Sergeant Mohammed showed and mentioned in the chat, 20,000 to 40,000 feet. Number 2, in what direction do jet streams flow? Yes, awesome, Sergeant E. They flow from west to east. Awesome job. And last question, where is clear air turbulence most likely to occur? Exactly. Sergeant Bukata, you got the answer right on, as well as Flight Sergeant Yao. The clear air turbulence is most likely to occur just above the central core of the jet stream. Yeah, awesome. So now we're going into the end of lesson confirmation questions. So question number 1, what must pilots be aware of when close to the ground during takeoff and landing? Wow, you guys are on the dot today. Yes, to Corporal Hersey, Sergeant Bukata. Yes, awesome job, and Flight Sergeant Mohammed. Pilots need to be aware of the direction of speed and wind, surface friction, etc., and the wind pressures as well. So question 2, can you guys list some of the wind phenomena in mountainous areas? Yes, Sergeant Picata, awesome job. You have 1, yes, mountain waves. Corporal Hersey, awesome, yes, cat catabatic winds. And also, yes, Flight Sergeant Mohammed, anabatic winds. Awesome. And lastly, what is the range of wind speeds in the central core of the jet stream? And this is a range. Very close, Sergeant Picata, and yes, Corporal Hersey, 100 to 150 knots, but can reach, yes, but can reach up to 250 knots. Awesome job. All right, you guys did absolutely amazing. Thank you for participating, and I hope you guys enjoyed the lesson. But this includes EOM 436.01, which is explain winds. Thank you guys for your participation, and yeah, other than that, that is the end of the lesson. I hope you guys had a great night. It's an extended night today, but I apologize. But yeah, have a great week and be safe. If you have any questions, you can stick back or you can comment them in the chat below. But I do not have anything else. And so if Officer Cadet Amoa does, then